Hello, everybody. Welcome to the AI Foundations course on Introduction to Machine Learning. And I am Parul, and I'll be your instructor for this course. I hope I am audible, and if you have any questions, you can please put it out there into the Q&A box or into the comment section, and somebody from our team will get back to you. So before beginning, let me just talk something about myself. My name is Parul, and I am a data science evangelist here at H2O.ai. My role mainly concerns connecting with the community and connecting the community to H2O's culture and its products. I'm also a Kaggle's kernel grandmaster, which means I have achieved one of the highest levels on the Kaggle platform in the notebooks category. And I'll take you through this entire machine learning module for the AI Foundations course. And I hope you really enjoy and you have some takeaway from this session. So this module is called Introduction to Machine Learning, and it will further have 4 sessions, beginning with session 1 today, which is framing business problems as machine learning problems. So before we move forward, let's just check out what did we study in the previous modules. So in the last session, we've already covered 2 modules. The first one was an AI transformation journey, where we basically understood the value of artificial intelligence and what is the value of asking the right questions about the problems that we are trying to solve. In the second module, we touched upon the artificial intelligence as a concept, and we understood that it lies at the cross-section of talent, tools, and resources. Today, we are going to touch up upon a very important part, a very important technique of artificial intelligence called machine learning. So just like I said, this entire module is divided into 4 sessions. The first one we are doing today, and the consecutive ones we'll be doing on this Thursday and then on next week on Tuesday and Thursdays. After session 2 and session 4, we will have a study group, which will be followed by an AMA session where you could ask any doubts or any queries that you have. So I think without further ado, let's begin. So the most important point that you all would be asking is why you all are here. And yes, we are here because we want to understand what is machine learning, what is the importance of machine learning, and how can we translate our business problems as machine learning problems. What you can expect in this module is these 5 important points that I'll try to cover during my session. We'll look at the need for machine learning. Why do we actually need machine learning in the first place? Some of the common use cases. We'll also design and evaluate some model architectures to convert our business problems into machine learning problems. We'll assess those cases. We'll finalize our AI proposal, and then we'll conclude it with a summary. Machine learning techniques are helping people all around the world to solve problems for the world, from advancing scientific discovery to helping doctors diagnose diseases. And that is why this makes this field so important. However, before we go further, just let me give you a reminder that this module is an introduction course to machine learning. Here you will understand the concept behind using machine learning and some of the terminologies and jargons, but a much deeper dive will be taken in the ML Foundation course, which begins after the AI Foundation course finishes. There you will have real hands-on experience with the coding, and with the other aspects of machine learning. So let's start with determining the need and use case for AI. So to begin with this part, I like to show you a small video clip of one of our customer, that is PwC, and let's see what Gary from PwC has to say.
My name is Gary Rapsey. I lead the innovation globally for PwC's assurance business. That business comprises roughly 87,000 people across 150 countries and with revenues of about $15 billion, so big business. I think on the planet today we're seeing that the rise of data and the rise of digitization produces its own problems. And I think in particular we're interested in how the capital markets and how companies work in this new data age, and how do we start to use technology and intelligence to actually make life better for people, make life safer for people, and make society better. But what I've observed in the products that we've built together with H2O's help is that there's a very different suite of skill sets of somebody who's a data scientist who thinks of a problem, and an accountant who has done things for the same amount of time with deep expertise, but done things in the same way. And part of the challenge was to smash both of those and fuse those together to say, well, actually, what if you could automate part of what you could do? What if you could challenge whether a human needs to do it and do it better than a human? And the other challenge for the data scientist is please understand enough about what an accountant does to start to use your infinite brain to help us do things better. And I think it's smashing those two things together that we found was incredible, both in terms of how diametrically opposed they were, but how incredible it was to watch products that were coming out of that fusion that were greater than either parties could have ever created. The challenge we set ourselves is, can we build an intelligent bot that's...
Okay, so this was Gary from PwC, which is one of our customer. And PwC together with H2O have created a machine learning product called GL.ai, which stands for General Ledgers.ai. Now, this was a pain point for PwC because they are into auditing and they had to rely on manual expertise to actually do all the accounting stuff and pinpoint errors and reduce risks. So what they did, they took their business problem and pain point and they converted it into a machine learning problem with the expertise of H2O. And we created a bot. We created an intelligent bot that spots the errors and frauds in the financial numbers. And this it does with an infinite level of speed and scale, which was otherwise impossible for humans to do. Now, there's a very important aspect that Gary emphasizes. He says, data science is a mix of domain experience and technical knowledge. And he says, how best can you actually fuse the two together will determine how successful your product will be. So he says, on one hand, the data scientists have the expertise of machine learning and artificial intelligence, and they could code and they could create wonderful products. However, on the other hand, there are people who have been working in this industry for years and they have a lot of domain experience. So both of them have to come together to create a wonderful product which is successful and which translates the business problem into a good machine learning problem and solves the problem that the company is facing. And this is a very important aspect of any data science role. Now, having said about this and having touched upon the importance of machine learning, we should know, and before we go into the details of what can be done with ML, let's talk about what is ML. ML, it stands for machine learning, and I would be using this short form a lot of times during this session. Now, you must have heard a lot about the terms artificial intelligence and machine learning interchangeably. But actually, both of these terms are different. AI is the science and engineering of making machines smart. And this field of artificial intelligence is not actually new. A lot of the ideas and innovations that you hear today originated in 80s. However, it is only recently that we've really had these powerful machines and large enough data sets to make major breakthroughs. And these breakthroughs are actually powered by a very special AI technique, which is called machine learning. So machine learning is a subset of AI. Whereas AI is a collection of many different technologies, machine learning is that technology which enables machines to learn from the past data. A very important thing to understand is that machine learning is a part of artificial intelligence. It's a very important part, but it's not the only one. So if I were to say in very basic term, I would say machine learning is an approach to help computers understand and learn from the data. Now let's see what is the difference between machine learning and traditional programming. Of course, both of them use algorithms, both of them use coding, but then what differentiates the two? If you talk about conventional programming, you pass in some data, you give it some rules, and you get an output. For instance, you pass in two numbers like 3 and 2, and you suggest a rule that is multiplication. So the output will be 3 into 2, that is 6. However, the difference in traditional and machine learning is in machine learning, you pass in some data, you also pass in the output, that is also called labels, and what you get are the rules, which means it is the machine which actually understands what is the pattern that links the data to the output. So for instance, you will pass in the data as 3 and 2, you will pass in the output as 6, and the machine or the model will figure out what is that relation between that input data and output. And when it figures out that, for instance, here it is multiplication, it will then can be used to apply this methodology to any new unseen data. To make it more clear, I'll show you through an example. So in machine learning, we teach a computer to perform a task by showing it lots and lots of examples. It is similar to how we would teach a child, for example, recognizing the image of an animal like a cat or dog. We show a child multiple images until he or she starts recognizing these animals. So in the same way, we train the machine learning system by feeding it images which are labeled. Labeled means that I would feed in an image and I would tell the computer or the program that it is a cat. Then I will feed in a lot of images of dog, and I will also tell the system that it is a dog. Over a period of time, the computer systems, they learn to recognize patterns in these images by being trained. So for instance, the program might uh, take the color of the animal as a feature. So it differentiates between the two animals based on the color, based on the position of their ears, based on the color of their eyes, nose, etc. So there can be millions and millions of such features. And over a period of time, these computer systems, they learn to recognize these patterns in these images, and by being trained, it starts to understand the difference between these patterns. And then in the future, if you give it an image which has not been labeled, the program will identify that image whether that belongs to a cat or a dog. Now, this seems very simple, but the ability to learn from the data has huge implications, and the problems that we can solve with this are many. So, we've talked about cats and dogs, but let me also give you an example which belongs to a very day to day example, and I think you would be able to relate with that in a much better way. Consider this person, and let's say he's Bob. Now, Bob wants to buy a car. He tries to calculate how much he needs to save monthly for that. And it's like we all do it in the same way whenever we need to buy a new item, a new car, a new house. So he goes over dozens of ads, he searches the internet, and what he does, he tabulates them in a spreadsheet. So he puts down two important things. He lists down the various models of the car, their age, and the price. Now, what he sees is he starts seeing a pattern. So he sees that the price of the car is dependent on its age. So the newer the car, the more expensive it is. And as it gets old, the price starts reducing by a factor of, say, $10,000. And so what has Bob done? So Bob has created a regression problem. He predicted the price based on some historical data, which is, in this case, was the car model and the age. And this is what we also do all the time whenever we go out there to buy some new product. And this is an oversimplified example of machine learning. However, here we are only dealing with two features, the model of the car and the age. What if there were tens and thousands of such features, like the company of the car, the color of the car, whether it's an SUV, whether it's a sedan, and so on. Now, doing such large calculations, it's difficult for humans. But who are good at this? They are machines. And for them, doing a repetitive task is very easy. So what we did, we took all that data, and instead of analyzing it manually, we fed it to the system. And this gave birth to machine learning. And this is a classic example of regression, which means we are predicting a numerical value. You will understand more about regression and classification in the next session. But for now, you can just understand that a regression problem is a problem where you try to predict a number. So if we've understood this example, I think we can list down the various areas where machine learning can be used. So machine learning can be used to solve descriptive problems, like what happened. And this means we take the historical data and we try to see what has happened, what are the important features in the data, and what the data is trying to tell us. Maybe there has been loss in the last 6 months in a company, or if you talk about from the stock market point of view, you could see that there were some stocks which had behaved very badly in the last few years. This is descriptive, like what happened. Another aspect would be predictive, what will happen. You will anticipate what will happen. For instance, stock prices or sales. How will my sales behave in the next 30 days? Will they go up? Will they go down? Or for instance, If you look at the current scenario, COVID-19, if you want to predict the number of deaths, the number of cases in the coming months or the coming days. And last kind of problems that we can solve with machine learning is prescriptive. Prescriptive means what to do. For instance, providing recommendations. Do you want product A or you want product B? I think YouTube, Netflix, there are some very good examples which offers us some choice, whether we should go with product A, B, we should buy this or we should buy that. So descriptive, predictive, and prescriptive are three kinds of problems or areas where machine learning is heavily used. So now I think we have some idea as to how we can convert a problem into a machine learning problem. But if we look at from the business point of view, let us now see how we can convert the business questions to ML problems. So we need to keep in mind three important aspects: how much, which one, and grouping. These are the three categories of machine learning solutions. For instance, how much questions, things like how much will each customer invest? What will be the price of the stock? Or how will the exchange rate change next week? Here we know the historical answers to these questions. We know that the customers invested last month and what the exchange rate was each day last year. But what we want to know is what these values will be in future. So we can forecast and predict with the help of machine learning. The next is which ones. Now, which ones question? It's a choice. We have yes or no questions, like which customers will churn or which customers will invest more than certain amount of money. Also, we could have multi-group questions. For instance, whether a person feels positive, negative, or neutral about a company, which is ideally called sentiment analysis. And for this also, we know the historical answers to these questions, but what we want to predict is either of the two categories. The third one is very interesting, and that's called grouping. Now, for these kind of problems, we do not have historical data. These are also called new inference questions, and we do not have historical answers to these questions. But we are just learning brand new information from this data. We have this data and we just try to identify patterns in the data. We could segment the data, we could cluster. For instance, we have a group of people and we are working for a shopping mall. And what we can do with the data is we could cluster this data based on age. We could cluster this data based on the gender, because females' choice of buying a product will be different from those of male. And age-wise also we can cluster the data, because senior citizens will have different needs than maybe teenagers. Teenagers would be buying video games, whereas senior citizens maybe would be interested in books. And so by clustering them, we could try and see a pattern. And hence we could send them mails or target our any product. So that's grouping or clustering, where we do not have any historical data. We can now reframe these questions from businesses to data science. We know our problem, we know what kind of business questions we have. Let's try and convert them into a data science problem. With this, we come to the part 3 of this session that's called Design and Evaluate Model Architectures. There's a very famous pyramid which is called DIKW, which stands for Data, Information, Knowledge, and Wisdom. The goal of data science project is also to turn the data into actionable knowledge and derive wisdom from it. And why do we need to derive wisdom? Because we need to answer a business question and transform the way that our business operates and interacts with trust and transparency. The initial data that we get is full of noise. We have to churn it, we have to remove what is not required and take that information and turn that into knowledge and wisdom. And how do we do that? We have a 5-fold architecture that we should follow or we can follow. We understand our business goals and expectations. We try to understand what we are going to achieve. If we are in a bank and we work for a bank, our business goal could either be reducing the churn of the customers or reducing the fraudulent activities of the customers. So we have to understand what is the main goal of our problem. Depending upon that, we translate into this goal into a data analysis goal. We try to get the data from different sources. We try to clean that data and we try to put in a end-to-end machine learning problem. Once we go from there, we frame a problem statement around that business problem. So if it is to reduce the churn, we are going to frame that problem. We'll take into consideration the various factors like customers' age, their education, their income, family size, credit history, etc. So in that way, we frame a business problem. And we'll also try to identify a success metric, because any problem without a success metric is of no use. You have to see whether your endpoint is to maximize something, maximize sale, or reduce the churn, or reduce the fraudulent activities. These are two different aspects. One is maximizing and one is reducing. And your success metric will vary depending upon what is your desired outcome. And once everything is in place, you have a good machine learning problem, everything is working, you have data, that entire framework should be accessible to people in the form of an application, in the form of a web app, anything that a company is comfortable with, but it should be open to people so that they can use it and we can see how things are changing in real time. If we dig a little deeper into all these phases, we'll understand some important aspects. For instance, during your understanding the business goals and expectation phase, it is not that easy how it sounds, because you have to begin by understanding the business vision. Does that vision align with your company also? What is more important to you? You have to identify a fraud that is taking place, or you have to identify people who are leaving your organization or your company. Next, you have to understand the main pain point that you are facing. There could be many pain points that a company faces, but you have to narrow down to few, because you cannot have a single machine learning framework solve all your problems at once. You have to look at different pain point, a different problem from a very different point of view. Very important is you have to see how many resources do you have. Do you have people to spare? Do you have infra? Do you have cloud infra if you want? Do you have access to databases? Do people have the relevant knowledge? Next, you have to also understand, will there be any potential benefit from the solution? Or the solution doesn't fit into the vision of the company. This is where you have to understand, how will the company benefit from these analysis? Or is there a problem which, when solved, benefit the company more? Risks. What are the risks in pursuing the project? By detecting the potential risks early on, you can minimize the negative impacts to get the best possible outcome. Realistic and attainable. You have to determine if the expected benefits are realistic and attainable from a data point of view. So you need to inform the company in advance if any of their expectations are unrealistic. So you cannot expect to have a 200% success rate in the machine learning problem that you are using when you're using the wrong kind of data. So all these things have to be informed to the management. Duration. You have to determine the duration of the project. Machine learning problems, they perform best for short-term goals. However, sometimes the company, they want to focus on longer-term goals. So you have to see and you have to find a sweet spot between them. And perspective. You have to always understand, and there is this problem with data scientists sometimes, that they are unable to look at a problem from the business point of view and from their client's point of view. If you do that, this will help you produce better results that will benefit both the sides. And domain knowledge. Like I said earlier, during the start of this session, you should ensure that you have the domain knowledge required for the particular problem. Now, a company is an expert in their domain, so you make sure that you understand their industry well. If you are working on a problem with a bank and you haven't worked in a bank before, ask as many questions as you need to ask from your client. If you've not worked in the pharma sector or the health sector, make sure you understand the question very well and you ask questions from those people, because the domain experience in such field is very, very important. Similarly, if you're trying to get into a job in a financial sector, make sure with the data science skills, you also go through the domain knowledge that is required for a particular company. So we went through the phase one, which was converting your business problem into a data science problem. Now let's see how we can translate our business goals to data analysis goals. For instance, and why do you need these goals to be clear? Because once your business goals are clear, you will actually understand what you're trying to achieve. For instance, consider two restaurants, A and B, and they both sell pizza. Now, restaurant A hires you as a data scientist and tells you that they want to increase their profits as compared to restaurant B. So now you have a business problem. Restaurant A wants to increase their profits. Now your work as a data scientist is to convert this problem into a machine learning problem. Now, what are the various ways in which you can translate this statement into an analytical problem? Which pizza is popular? Which pizza is the least popular in restaurant A? How does the price of items at restaurant A compare to that of restaurant B? Are they higher? Are they lower? Or are they same? How many customers does restaurant A have as compared to restaurant B? What are the peak hours at restaurant A and restaurant B? Is there some convergence? So maybe the peak hours are the same and hence there's a lot of competition. What is the footfall at each restaurant and so on? These are the questions which you as a data scientist would ask restaurant A's owners or the management to frame a problem. So when you put all these down on a paper, you notice that restaurant A is selling less pizza as compared to restaurant B. And this changes the entire problem statement because the problem statement with which you started was how do we increase the profits of restaurant A? Now your problem statement is how do we sell more pizzas, like more than B or more than other competitors? So when you translate your business goals to data analysis goals, you see a clear picture of the problem that you're working on. And once you know your problem, you have to see, for instance, you can frame your problem in such a way. The problem B has the impact I, which affects B. So a good starting point would be S. So this statement describes your problem, why solving the problem is important, and a starting point to begin solving it. So I have highlighted P, I, B, and S. The problem P, you can insert your problem as the company defines it. I stands for impact. You can insert the negative impacts or the pain points of the problem. B, which is the thing that is being affected. So you can insert the parties that are being affected. It could be the business, it could be the customers, it could be the third party. And lastly, S. S stands for starting point. You can insert the benefits over here. So if we look at the pizza scenario, we can put the problem in this template as the problem of low pizza sales has the impact of decreased profits, which is the pain point, which affects restaurant A. So these are the affected parties. So a good starting point would be to compare their pizza price with that of their competitors. So reducing the price might be one of the solution in getting more sales. And there could be many such answers that you might get. Let's come to the part 4, which is now assessing key use cases. Now you have created a problem, you understand your problem very well. Now, how will you assess? How will you assess whether the sales that are happening now after using machine learning is something that you're desired for? And for that, you need a success metric. You need to assess and you need to benchmark. So model assessment would mean performance or accuracy. But for this problem, you could benchmark. You could benchmark that you have to increase the sales by 20% in the first month. So by reducing the price of pizza by 10%, you intend to increase your sales by 20% in the first month. And after first month, you assess and you see, yes, my sales did increase by 20%, so everything is good. But if the sales did not increase by 20%, you have to reassess your strategy. At a broad level, solving business problems with data and machine learning requires a combination of business analytic patterns. Although they're often indicated in a life cycle, the actual application of these patterns is more iterative. So you have to go through the cycle again and again by benchmarking and assessing the final result and comparing it with what your business vision was. So let's just put into perspective what could be a pattern of analytical business problem. Say a bank wants to optimize its loan underwriting procedures. That's a very common use case in which machine learning is used. So currently, it applies filters on loan applications, and those filters will automatically reject the riskier ones because a bank doesn't want to give a loan to a person whom it feels will not pay back. So it has a filter in place and it automatically rejects them. However, the bank is still approving too many applications which run into repayment issues. So what the bank does is it collects a large amount of data for each loan that it has approved in the past. And this data consists of a lot of fields. For instance, there could be amount of the loan, the interest rate, the demographics, like the age of the person who took the loan, the salary of the person, home ownership, and some risk factors also, like credit card details, bankruptcy information, etc. So you collect all this data. Your goal would be to create a predictive model to identify loans which might turn bad. And this is actually a real use case. But if you look at your data, no field indicates whether the loan is good or not. So what you do? You create a machine learning problem out of it. Looking at the previous data, you will define a way in which you will be able to predict which loans will turn bad. But how do you start? As a data scientist, you need to sit down with the customer to understand the business problem. Your first goal will be to articulate the overall business problem. Can I detect attributes about a person or a type of loan that can be used to flag a risky loan? And you have to ask these questions from the bank officials. Once you ask a lot of questions from them, you could do one of the four things. You could segment those loans into different categories, depending upon the purpose for which they were taken. You could sort the customers into different groups, depending upon their demographics, their age, their area from where they come. You could also discover patterns that cross all three types. So now what will happen is you would get an idea. So people from that area default a lot, or people who have a bad credit score default a lot, or maybe people who have a higher education tend to repay back. Using all this information, you are going to put into your data, and then you will understand the business problem and see past historical data, and hence you will formulate a new business problem where you'll be able to predict which loans will go bad. Once you do that, once you create your model, once your machine learning model is able to predict things, you need an end application. For instance, at H2O, we have Q app, which is an AI app which can help you gain insight, intelligence, and prediction through just one screen. And as you can see on your screen, you can actually see the sales, the forecasted sales, uh, and this is a business problem where the effect of COVID was seen on sales. And you could see as an end user, you will be able to see the entire pattern on a screen. So having an AI app through which the people can actually understand in through a single screen what is happening, how things are changing, how sales are increasing is also very important when you create a whole end-to-end workflow of your machine learning problem. So after we have done everything, you have a problem, you have data, you have the required domain knowledge, it's time to finalize your AI proposal. And how do we do that? By asking three important questions. What data are we learning from? Do we have enough data? How are we using the predictions which we have got? And finally, how are we making sure that the whole thing is working? So these are the important three aspects which we need to know to understand whether the entire framework is actually successful or not. And for this, we can use a canvas. A canvas is nothing but it's a feature which can help you keep track of every aspect of your workflow. It helps you to describe precisely every aspect or every feature that you are trying to undertake while creating a machine learning problem. So if you see at this canvas, you are going to see there are a lot of blocks which have been made. And let's just go through each block one by one. So there is a central block here, which is called value propositions. Now this value proposition of the system helps you answer three important aspects, that is what, why, who. What are we trying to do? Why is it important? And who is going to use the system? The part on the left-hand side is dedicated to predictions based on the models that will learn from data. So these are made up of 4 different blocks. Your machine learning task. So what is the type of machine learning problem that you are using? Decisions. How are the predictions used to make decisions? Making predictions. When do we make predictions on new inputs? And how long do we have for that? And finally, offline evaluation, which means using metrics to understand whether your machine learning predictions work. On the right-hand side, this portion is dedicated to learning from data. Again, it is made up of different blocks. For instance, kind of data that you're collecting, what is the mechanism, what are the different features. So if you don't understand all of them, don't worry, we will go deeper into the next session. But what you just need to understand is by using this canvas, you can really simplify the whole data science workflow by assigning them to each block. Again, responsible AI, responsible machine learning is an important aspect which needs to be considered when you are creating your data science workflow. You should be able to explain and interpret the result of a machine learning model. Further, This portion determines how you evaluate. What are the things on which your machine learning model is being evaluated? Could be through an app, could be through some business processes, could be through feedback mechanisms. So predict, learn, evaluate, a cycle which forms on an AI canvas can really help to put things into perspective. So what's next? Well, let's just go over the things that we have covered so far. We've determined the need and use case for AI. We understood how we design and evaluate our model architectures, how we assess the use cases, and then we just finalized and combined all of them into an AI canvas. The next session on myth versus reality, the data science workflow explained, will be held on the coming Thursday at the same time. The quizzes and study groups will be there after the second module, after each module, and after the second session on Saturdays and Sundays as AMA and a study group. And there'll also be a quiz on the session that we have covered today, and you can just pass the quiz to earn your badge. Some of the resources which you can now go and look for to understand more about the data science problems are the H2O's glossary, which will give you an understanding of some of the terms which are used in this session. There are wonderful white papers and case studies on H2O's site, the link for which has been given here, and some of the blogs which you can go through to understand some of the use cases and how we are using machine learning at H2O. And with this, I conclude today's session. If you have any doubts or queries, you can ask right now, or we could connect in the study groups and the AMA session. Thank you.
Thanks, Pearl. If folks have questions, please use the question and answer module, and we'll, wait for that. And I think, the Siam, who's the instructor for the question and answers on the weekend, really wants to encourage, and I want to encourage folks to kind of attend that. If you have further questions beyond what's here, or you want to kind of dive deeper and have a little more informal discussion where it's an open mic for everyone. I don't know, Siam, if you want to add anything else you wanted to add.
Thanks for the mention, Rafael. I just look forward to meeting everyone. Just as a reminder, no questions are too silly, and these won't be recorded for your benefit. So please do join, ask as many questions as you want. There'll be 2 calls on Saturday and Sundays, and I look forward to meeting everyone there.
Thanks, Siam. So there's a question, Pearl. I find the machine learning canvas very interesting. Will it be explored further in subsequent sessions?
Well, I think the machine learning canvas actually gives you a template, and as the sessions progress, you will be able to actually, you can choose current problem, data science problem that you are working on, and try and plugging it into the AI canvas. And then we would like to actually get your perspective on how helpful has this canvas been for you. Yes, this canvas is downloadable. This is freely available, and I'll share a link with you people.
There's another question, Pearl. While we frame the business problem and data analysis problem, can it end not an ML and AI problem, and can it be set for a statistical or rule-based solution? And is there any use case on it?
Well, I think that is a very nice question. And yes, it does happen that there are some problems which can be even solved without machine learning, but that aspect gets covered into the first few interactions that one might have with the clients. As far as H2O is concerned, we don't really have a use case on that, but would be open to hear from other people where they've encountered such situations. But yes, definitely, you can use rule-based also.
Yeah, I think there's so we have capability to kind of build decision trees, which are not necessarily rules, but I think we also have some capabilities to generate some rules. There's a series of algos called rule fit. We're still leveraging machine learning, but we're sort of generating machine learning to kind of come up with rules. And that's a good fit for places where they're using rules already and maybe can make the full switch to machine learning, but can we leverage machine learning to build better rules, right? So that is sort of an option. Okay, I think that's the last set of questions. Thank you very much for joining this machine learning introduction with Parul. The slides and the replay will be posted within about a day. We look forward to seeing you again next Thursday, same time, and have a good day or a good evening.